So hi techies, welcome back to the channel, and in today's video we will be making another machine learning project which is loan approval prediction, and this is the data set which we will be used, which you can see on the screen. And before starting the project we will first listen to the problem statement. So basically leave machine learning project or anything right now. Suppose you work in a data scientist at a bank. Suppose you have suppose imagine that you work as a data scientist at a bank. Every day the bank receive numerous loan applications from customer. Reviewing each application manually is time consuming and may lead to inconsistent decision. Your task is to build a machine learning model that predicts whether a loan application should be approved or rejected based on application details such as income, education, CIBIL score, loan amount, loan term, and asset values. This model will help the bank make faster, more accurate, and data-driven loan approval decision. So are you getting my point? This is the problem statement. Okay, and based on this we have to make a project like a loan approval prediction. And next I will tell you that what will be the workflow of this project. So for that I will tell you the workflow. So first of all we will have our problem statement. We will have our problem statement. Next is we will import libraries. Next we will load our dataset. Next is data understanding, and I will be explaining all you these steps in very elaborating, so don't worry about that. Next we will be doing a data cleaning, which is a very important step. Data cleaning. Next is EDA, correlation analysis. Next is our label encoding. Train, test, split. Next is our algorithm which we'll be using. So basically 3 algorithms I have decided to use in this project. Next is logistic regression, decision tree, random forest, and last will be our model comparison. Okay, so this is a workflow of our project and we will be starting with it now. So before we start, I will just tell you the data set from where you have to download it. So you can download the data set from Kaggle, and I will be sharing the link of this data set. So you just have to come over here and you just have to copy this. And we will be making a project in Google Colab. So for that, let's start. I will open a new tab, Google Colab. I will be typing over here, and I will be making a new notebook over here, and I will be keeping it name as, just a second, the name I will be keeping it as loan approval underscore prediction. This will be the name for loan approval prediction, and I will be connecting it, and I will be sharing this with you all. I will make it public and share with this you all, and also upload it on LinkedIn. So you don't upload it on GitHub and share the link with of that repository with you, so that you can see the you can download it or you can refer to this. I'm making it public, and I will be sharing it with you. Okay. So for before that, let's start with I've told you the problem statement, so I won't be writing the problem statement over here. The problem statement is in front of you. On the basis of it, we will be making a project. Okay. So before that, first step is, and you have requested, like people have mailed me to like make understand you the code more clearly. So I would be writing from now onwards, I will be writing complete code so that you can understand it. Import libraries. Okay. So what are library we will be importing? So basically for data manipulation, I would be importing, just a second. Import pandas as PD and import numpy as np. Import. So basically what all this library do, first pandas is basically give you the data frame, like df is we will be using df, inside that we will be saving that data set. So basically provide a data. See, the machine learning algorithm cannot understand the data directly, they need some structure or framework so that where they can extract the data. So pandas help in that. Numpy will provide us the numerical value, in that numerical analysis and all that we will be doing, Numpy will be helping us. So, and what is import pandas as PD? So PD and NP are the LIS which are we using. Okay. So I would be writing over here, it is used for data manipulation, and it is used for next library are for data visualization. See, for understanding the data, we have to visualize it. So the next few libraries which I will be writing will be helping us to visualize the data. Import matplotlib.pyplot as plt and import seaborn as SNS. So basically matplotlib is a library which help us to like visualize. It has like a histogram, bar graph, pie chart and all that, and seaborn is so you can understand it as an advanced version of matplotlib. It has more, like you can visualize more type of data set in that, so it will be helping with that. And plt over here is again the alias or the short name for this library, as and so goes for SNS. Okay. So understanding which all library which will be using is very important. So I've written over here so that you can understand it. And next I will be running it so that this could be run, and I will be like extracting more piece of code because many like code which will be using over here. Okay. So now very important steps, load the data set. See, without data set we cannot make any project. So step 2 is our load the data set. Okay. Now I will go to Kaggle. As I have told you, again I will just refresh it so that you can also be on the same page as I am. I will go to download. See, there are two ways to access this data set. First is download as zip, and so I can extract in my like extract in my like upload it on Google Colab. But in this method, every time you open the Google Colab, you have to upload the data set. So I will be using this method, which will be we will be using the API key of the Kaggle and will be using in a project. I've copied it from there and I will be just pasting it over here. Okay. Now I have got the path. Okay. So in that path, next step would be df is equal to pd dot read underscore csv, and I will be pasting that path. Okay, so just I have to check. So what I have done is I have saved that path was this. So I've imported a library OS. Inside that I have used list directory and the path of. So the path I have got is this. Earlier I was accessing the folder inside that. So I can't access the folder. I have to access the CSV. And now I have inside DF. I have stored pd.read underscore CSV. It is the PD is the pandas library, and DF is the name, which is a data frame, and os.path, and I'm joining path and loan approval dataset.csv. So basically this is the dataset which we are having. So, and if you want to check that it is right on wrong, you just have to write down df.head. Okay, once you write down df.head, you have got all the dataset values, and these are all the columns. So we have loan ID, number of dependents, education, and all that. And based on all this column, we can see that our loan is approved or rejected. So basically this is our objective, that I will give you, or the manager will give you all this detail, and you have to tell that the loan is approved or rejected. So this is a very important thing which I am telling you. So these are the dependent features, you can say, and loan status is the independent feature. So these are the independent feature, and loan status is the dependent feature based on rest of the all the columns. So for loan status, like commercial asset value will be mattering and everything will be mattering. Okay. So let us check the column names. For that, I would be writing check column names. So we have df dot columns. Now we have all this column, loan ID, number of dependent. One thing I can see that there is a space between them. This is not good. We will like changing this in the coming step, and rest we have all this column. So on basis of all these columns, loan status, we will be telling that it is accepted or rejected. Next is our step 3, understanding the data set. Okay. So why to understand the data set? So basically, before performing any data preprocessing or model building, it is important to understand the data set. In this step, we will examine the data sets, dimensions, column name, data types, and summary statistics to gain insights into structure and identify any potential data quality issues. Okay. So we will be now checking the data set shape. Check dataset shape, df dot shape. Okay. Oh no, this will not be here. So basically there are 13 columns, as we have seen. You can count it if you have time, and we have 4269 rows. So it is a quite big data, and it would be helpful for us. So basically, the shape function returns the dimension of the dataset. It tells us that our dataset contains 4269 loan applications and 13 columns. Okay. Now, I will be again displaying the column name, and we will be doing the thing which I will told you earlier, that removing that extra space. Okay. So for that, I will be doing df.columns, and we have got it. Next, we will be removing the extra spaces from column name. So remove extra spaces from column names. df is equal to columns is equal to df dot columns dot str dot strip. This is the code to like remove all the extra spaces in the columns, and you can verify also with df dot columns. Now you can see there are no extra space. So a question would be arising in your mind that why we are doing this, why we are removing this. So basically, when working with real world data sets, column name may contain unnecessary leading or trailing spaces. Removing these spaces ensures that column names are clean and prevents error when accessing them later in the notebook. Okay, so to avoid errors, basically we are removing the extra spaces, and it is a very good practice. So always just see, identify your column name, and if there are any extra spaces, just remove them. Okay, and this is a single piece of code you can use, and everywhere you can just remove the extra spaces. Now we will be displaying some random sample. See, for telling you the df dot head we have for the first 5 values, and df dot tail we have for the last 5 values, but we will be displaying some random values now. So display random samples, and the code for this is df dot samples, and how many you can write, I am taking 5 over here. If you want 10, you can take 10 or any value you want. Okay, so df dot sample, it is not samples, sorry, my bad. Okay, now basically why we are displaying the random samples. So instead of always using the first 5 rows which head, sample shows random record, helping us verify that values look reasonable across the data set. Okay, so these are the sum of the 5 random value. It can be at the position 1000, 2000, 1600, 1800. It is some random value, like the OTP which comes, it is a random value. So like that, these are the first 5 random value, and we will be trying to understand what a data set is. So you can see that we have loan ID, we have number of dependents, and everything we have in this data set. Okay, next, our step 4 is data set information. Now we will be extracting all the information from this data set. So step 4, there are around 13 steps, and by after 13 step, like you will be have made your whole project. So be with me, and you will be understanding all the things, all the code. No, we will having no problem in understanding. Okay, now we have our dataset information. So what we are doing in this step? So basically in this step, we will examine the dataset in detail by checking the data types of each feature, identifying missing values, and generating summary statistics. This helps us understand the quality and characteristics of the data before performing pre-processing and model building. Now, we will be extracting some dataset information. For that, you just have to write df.info. Okay. So you have loan ID and non-null count, there are non-null. So one hack I will tell you, see, if there are non-null value, this is a basic machine learning project. If there will be like null values, we have to like do the like mean median mode. By that we have to like convert all the values into like usable form. So it becomes a little complex project, and it is not a basic machine learning project, but this is a machine learning project. And data type, which you will see that there are only 3 columns which object data type. This will be like we have to change it into integer later by doing encoding, and I will be explaining you that. Now we have reached so far, but can you tell me that it is which type of learning? Like it is supervised learning, non-supervised learning, and it is a project of classification, regression, or anything, or which thing? You just guess. See, in this project we have to predict the loan status is approved or rejected. yes or no. 2, binary, 2. So it is a supervised learning machine learning project. Why? Because it has data is column labeled data. We have columns, so it would be a supervised machine learning project. Now it would be a classification or regression. Classification project always returns at the end yes or no, like true, false, or spam, not spam type of thing. And regression project always returns numerical value, that the house price prediction and all that. So in this project our end goal is to find out if the loan status is approved or rejected. So obviously it will be a classification project. So identifying which type of project it is very important itself. Okay, if you don't know what type of project it will be, doing all this thing will be useless. Okay, so you can see over here we have all these columns and we are having all the values not null, which is very good, and we have like integer, mostly are integer, and we have some object which will be converting them into integer later. Okay, so what does the info functions provides? So basically the info function provides a concise summary of the dataset. It displays the total number of rows and columns, the data type of each feature, the number of not null values, and the memory usage. This helps us identify missing values and understand the structure of the dataset. Okay, so basically I will be covering some of the interview questions also, like if you like showcase your project in your this project in your resume by seeing this video, what type of questions can the interviewer ask from you? I will be covering that also. Okay, so why does we use df.info? Basically to understand the structure of the dataset, check data types and identify missing values before pre-processing. Now for statistical summary of numerical features. df dot describe. Now what are these are the columns, you know, and what are all this? Basically count is the like to count is total number of count. Okay, how many applicants? So as I've told you, 269 are there, so these are all the count. Okay, mean is the sum of all the numbers by total number of numbers. So loan ID will be like we are summing all the loan IDs and dividing by 4269. Standard deviation is something like how much data is like deviating and not, like that kind of thing. Minimum, the minimum value is 1, like the loan ID I think is starting from 1, so that is minimum. 25% is how much data is 25% of the total. It is 1068 over in this column, and every column had different. Okay, like that 50%, 75% is there, and maximum is the maximum value. So loan ID start from 1 and at 4269. So what will be the minimum? Minimum will be obviously 1 and the maximum will be 4269. This goes for all the columns, and if you have time you can check from the data set also. Okay, now I will tell you summary of categorical features. Summary of categorical features. I would be writing df dot describe include is equal to object. Now I have told you 3 columns were there for object: education, self-employed, and loan status. Education, self-employed, and loan status. Count is 4269 as it is not null, so everything will be filled. Unique, there are 2 elements, top is graduate and self-employed is yes, and frequency is also over here. So basically this help us understand the distribution of the categorical data. Okay, now step 5 will be data quality checks. Step 5, data quality checks. So, before building a machine learning model, it is important to verify the quality of the data set. In this step, we will check for missing values, duplicate record, and unnecessary columns. Ensuring clean and reliable data improves model performance and reduces the chances of errors during training. Now, though we have got that there are no missing values, but still it is a good practice if you check every time for missing values. So I will be writing check missing values. Df dot is null dot sum. See, there are no missing values. It's a good thing. So the is null dot sum functions check each column for missing values. Missing data can negatively affect machine learning models, so it's important to identify and handle them before training. Again, an interview question. Why do we check for missing values? We could have skipped this part. Again, why I'm emphasizing you to check for missing values? You just tell me that. Missing values. So answer is, and you can answer it into the interviewer. Missing values can lead to inaccurate predictions or errors during model training. Identifying them early allows us to decide whether to remove or impute them. Now, we will be checking for duplicate records. It is also very important. Check duplicate records. Df dot duplicate dot sum. So basically, duplicate records can be biased the model by giving more importance to repeated observation. Therefore, we check for duplicates and remove them if necessary. So here we are not removing because there are no duplicates itself. Okay. Now we will be checking for unique values in each column. Check unique values in each column. For that, df dot n unique, and yeah. So basically this gives us the idea of numerical features, categorical features and identifier. It also helps us to decide which column may not be useful for prediction. Can you guess from here? Just guess, like among all this column which will be not help us for prediction. Loan ID. Loan ID will not be mattering at all. In our employee, another project which I made like a month ago of employee will be leaving a company or not, there also I have removed the employee ID because it was not helping me. Here also I will be removing the loan ID because it will not be helping in my prediction. So for that, remove the loan ID column. For that, I would be writing df dot drop comma axis is equal to 1 and in place is equal to true. Just a second. Now you would be thinking that what you have written, so I would be telling us from the framework df dot drop, I am dropping a loan ID column Axis is equal to 1, that means I am dropping a column. If axis was 0, I would be removing an row. And in place is equal to true is that basically I am changing the original data set. Okay, so if you check that df dot head, you just check now. From the original data set, loan ID has been removed. So in place is equal to 2 does that. Okay. So loan ID is the only a unique identifier and doesn't provide any information that helps predict whether a loan should be approved or not. So that's why I have removed it. So basically, if you can furthermore understand, I could say that the loan ID column is simply a unique identifier assigned to each loan application. Since it doesn't influence the approval decision, we remove it before training the model. It would be an interviewer answer. Okay, if he sees and if he comes here and see that why you have removed the loan ID column, you can say it to him. Now, suppose your interviewer asks us why shouldn't ID column be used as input features. So you can just answer that they uniquely identify records but don't contain meaningful information for prediction. Including them can introduce unnecessary noise to the model. See, we want a clean data to do the algorithm process. So that's why we have removed it. So after checking the data set, we can see that there are no missing values and no duplicate record. This means our data set is already clean and we don't need to perform any missing value imputation or duplicate removal. Now, I will be checking our target variable distribution. Can you just tell me what is a target variable? Yes, loan status. We have to, the problem statement is saying that if the application is approved or rejected. Let me make some few more columns. So df of loan status dot value underscore counts. Okay, so out of 4, 2, 3, 6, 9 something, 2, 6, 5, 6 are approved and 1, 6, 1, 3 are rejected. Can we see it in percentage also? Yes, we can. df of loan status dot value underscore counts normalize is equal to true and into 100. 62% of the applications are approved and 37 are rejected. Okay. So why we are doing this? So before training a classification model, we need to know whether the data set is balanced or imbalanced. If both classes have similar number of record, it is balanced data set. If one class dominates the other, it is an imbalanced data set. So this influence more selection and evaluation matrix. Now, a very important step, EDA. Step 6, exploratory data analysis, which is EDA. So basically, EDA is a process of analyzing and visualizing the dataset to understand its underlying patterns, relationships, and distribution. It helps identify trends, detect outliers, and gain valuable insight before building a machine learning model. So now we will be analyzing our target variable. So for that, analyze the target variable. We have df of loan status dot Well, see, in this project, I won't be teaching you Python. So this Python is the prerequisite of this project. So if you are thinking that without Python, you will be understanding this project, no, and you will be facing it very difficult if you don't know Python, that what I am writing. But if you know basics of Python, not like in DSA terms of Python, you will be understanding. And in future also I will be like making a complete playlist for Python, but currently you have to like study from other YouTube channel, or you can refer to a book, website, anything, W3 schools and all, to understand Python, and then you can come to back to this video and understand all the things. Okay. So let's first analyze our target variable, which is loan status. Since this is a classification problem, it's important to understand how many applications were approved and how many were rejected. This helps us determine whether the data set is balanced. So first visualization graph I am making now, and please see it very carefully. So it will not be a very big, that's why I am taking the size at 6,4. SNS dot count plot data is equal to df comma x is equal to loan status. Plt dot title, the title of the this I will be giving as loan status distribution. Loan status distribution. Okay. And x label will be x label loan status, and y label will be count. And now you just tell me, I have written all the things which will this it would be showing. Just run it. Okay. Plt dot show. See, now it is showing us completely. You can see that this is approved one, this is rejected one, and it would be like 2565 over here, and this would be 1639 1613. So this is loan status distribution, and over here in x-axis we have loan status, y-axis we have count, and these are the numbers. Okay. So now if the interviewer asks you, why do we analyze the target variable first? Because it helps us understand the class distribution. If one class has significantly more samples than the another, the dataset is imbalanced, and we may need techniques like class weighting, oversampling and undersampling. Okay. Now I will be like adding the percentage distribution. Add percentage distribution. Df of loan status counts normalize is equal to true into 100, round is equal to 2. Now you got why I've written round is equal to 2, basically to get two decimal values after decimal. Okay, so that's why I've written round 2. Now So basically normalize is equal to true is what it is doing. It is like converting the numerical into the percentage thing. So like approved were 2656 and after normalizing it is becoming 0.62%, 62, and likewise rejected was 1613 and after normalize is equal to 2 it is becoming 0.37, and into is like converting it into multiplying by 100 is making it into percentage. Okay, so it becomes 62.22 and 37.77. So the target variable is loan status, which contains two classes, approved and rejected. We observed that approximately 62% of loan applications were approved while about 38% were rejected. The dataset is reasonably balanced, making it suitable for training classification models without requiring special techniques to handle class imbalance. So if an interviewer asks you, is this dataset balanced? Yes, although the approved class has more records than the rejected class, the difference is not extreme. Therefore, the dataset is reasonably balanced and can be used for training classification models without immediately applying resampling techniques. Now, we will start with the actual EDA. From here onwards, we will analyze each feature and answer two questions. How is the feature distributed? Like it can be univariant analysis, and how does it affect loan approval? Bivariant analysis. Now we will be analyzing the education, like we will be seeing that is education mattering in that loan status education column. So first is our analyzing. We will be like comparing 2-3 column, but first is our education. I would be telling that what we are doing. Let me write df dot head over here. So like we are seeing that is education affecting loan status. We will be comparing 2-3 columns and then we will making the prediction. So just a second. Yeah, so we were like analyzing the education, and for that df of education dot value counts, and here are 2144 graduates and not graduates at 2125. Okay, now we will be making a distribution graph for it so that you can easily visualize it. I would be writing plt dot figure fixed size is 6,4. SNS dot count plot x is equal to education and comma data is equal to df. Next we have plt dot title distribution of education. For that I would be writing plt dot x label, that is education, and plt dot y label, that is number of applicants. Plt dot show. Okay, so it is approximately the same. So basically I would tell you SNS.countPlot is a function used to count the number of occurrences of each category and display them as bars. Okay, so I've written over here. See, I would be explaining all the code. You don't think I'm just writing it over. I will be explaining after writing. Okay, so SNS.countPlot x is equal to education, comma df is equal to df. X over of education represent use the education column, and data is equal to df, the data sets from which the column is taken. You don't need to calculate the counts yourself. Count plot internally performs a value counts and draws the chart. So this count clause show the distribution of applications based on their education level. It helps us to understand whether the data set contains more graduate or more on non-graduate before analyzing how education influence loan approval. Now, I would be comparing it with loan status because that is a target variable. SNS dot count plot x is equal to education comma of loan underscore status comma data is equal to df. Let's see. So based on the current visualization, both graduates and non-graduates have similar proportions of approved and rejected loans. This suggests that education alone may not be a stronger predictor of loan approval. However, we cannot draw a final conclusion without further analysis and model training. Next feature which we can take is, let's see, df dot head, and I can take off self-employed, see if it is affecting or not. So next feature is, next column I will be targeting is self-employed. So in this section, we will analyze the distribution of applications based on their employment status. This helps us understand how many applicants are self-employed versus non-self-employed before examining its relationship with the loan approval. Now I will be writing df of self underscore employed dot value underscore counts. And yes, you have 2150 and no, you have 2119. Now we will be making a distribution for this also. For that, I would be writing plt dot figure, and figure size would be 6,4. Next, I would be writing SNS dot count plot x is equal to self underscore employed comma data is equal to df. plt dot title is distribution of self-employed applicants. Distribution of self-employed applicants. Perfect. X label would be self-employed and Y label would be number of applicants. And plt dot Y label self-employed. And next we will be writing plt dot show. See, plt dot show is writing very important. So we have got it. Okay. Now we will be comparing it with loan status. That is our objective. So for that I would be writing plt dot figure fixed size 6,4 SNS dot count plot x is equal to self underscore employed comma is our loan status and data is equal to df. Now plt dot title I would be keeping as Loan status by self-employment. Loan status by self-employment. And PLT dot X label is self-employed, and PLT dot Y label number PLT dot. So this visualization helps us understand whether self-employment has any noticeable relationship with loan approval. By comparing approved and rejected application status across self-employed and non-self-employed applicants, we can observe whether employment type appears to influence the approval decision. Now, we can also do the income analysis, but leave it. We can do something of correlation analysis. Okay, so now we have step 7, which is correlation analysis. So correlation measures the strength and direction of the relationship between numerical features. A correlation heat maps help identify highly related variables, detect multicollinearity, and understand how different financial attributes are associated with one another. For that correlation, I would be writing PLT dot figure fig size of 12,8 correlation is equal to df of select the types include is equal to number dot and SNS dot heat map. Correlation and not is true over here, and CMAP is cool form. And FMT to F. PLT dot title correlation heat map. Heat map. PLT dot show. Okay. We, SNS dot heat map. Okay. Correlation. See, these are the errors. I won't be like cutting the video and giving you the mistakes everyone makes, and by these error you understand the code. Okay, so this is the correlation heat map which you can see on the screen. So basically, a correlation heat maps help us understand how numerical features are related to each other. Correlation value ranges from -1 to +1, where +1 indicates a perfect positive relationship, while -1 indicates a perfect negative relationship, and 0 means there is no linear relationship. This analysis also help identify multicollinearity before training machine learning models. Next, we have data pre-processing. Step 8, data pre-processing. So basically, machine learning algorithms require numerical input data. In this step, we prepare the dataset by encoding categorical variables, separating the features and target variable, and making the data ready for model training. Now, I would be checking the data types. Check data types. So for that, I would be writing df.info. You can see that three are, as I've told you earlier, which are object. So education, object, self-employed is object, and loan status is object. These are columns that need to convert it into numbers. Why do we encode? So basically, machine learning algorithm works with numbers, not text. Objects are basically text over here. So for encoding, I would be writing something like, just a second. Uh, so for encoding, I would be writing from sklearn dot pre-processing import label encoder label underscore encoder becomes label encoder. Okay, now for this column I would be making for first education. Education is equal to label encoder dot fit underscore transform df of education. And same for self-employment, and all the remaining two I would be writing. Here would just come self-employed. Here will come loan status. So this is like the encoding which I have done. So first understand the fit transform which I have written over here. Okay. So basically this is one of the most common interviewer question. What does fit do? It learns the unique categories. What does transform do? It converts them into numbers. Now you can see one of the changes which I would tell you in the dataset df dot head. If I write over here, it becomes, now see, for education it has become 0 1 right now, self-employed also, and loan status it was previously approved or rejected, but it has now become 0 or 1. Why? So that our algorithm can understand it clearly. So basically continue. Huh. So machine learning models cannot process text directly. So we convert categorical variables into numerical values using label encoding. Since our categorical features have only two unique categories each, label encoding is simple and appropriate choice. Now, if the interviewer asks you why did you choose label encoding instead of one hot encoding, the answer would be we use label encoding because all categorical features, education, self-employed and loan status are binary, meaning they each have only two unique categories. For binary features, label encoding is simple, efficient and does not introduce unnecessary additional columns. One hot encoding is generally preferred when a feature has more than two categories without any inherent order. So I don't want to encode all three columns using the same label encoder object as many tutorials do. It works here, but it is not a good habit. Okay. So for that, a cleaner approach would be, just give me a, yeah, so I've written the code for this. That's why I paused the video so that I can write and your time would not be way pasted. You can just copy paste the code from here. Next, we have the step 9. Step 9, feature selection and train test split. Feature selection and train test split. So before training a machine learning model, we separate the dataset into input features X and the target variable Y. We then split the data into training and testing set. The training set is used to train the model while the testing set is used to evaluate how well the model performs on unseen data. Now we have separate features and target. So for that, my X will be df dot drop of loan status comma access is equal to 1 and my Y will be df of loan underscore status. So what I have done is that separated both, like from this whole let me explain by this. All these features are into X and this loan status is in Y. Okay, I have separated both and now I will run it, and to verify it I would be writing print X of head. See, it is having all the feature but not loan status. Loan status is inside Y. So I would be writing print y of head. See, y is inside that 0, 1 and all that. So basically, if the interviewer asks you why do we separate x and y, you can say that in supervised learning, the model learns the relationship between the input features x and the target variable y. Separating them is necessary because x is used for prediction while y contains the correct answers using training. Okay. Now we will perform train test split. So from sklearn dot model selection import train test split. Okay. Next we have x underscore train comma x underscore test comma y underscore train comma y and tab. I will enter all the it is giving y train test split and x comma y comma 0.2 and this. Now let me explain you what is all this random and test size. So basically here 0.2 means 20%. So for testing I am taking 20% and for training I am taking 80%. This means that random state 42 is basically this fixes it the random split. This fixes the random split. So without it, every time you run the notebook you will get a different train test split. Why 42? See, there is nothing mathematically special about 42. It's a common use seed value. In example, you could use 7, 10, 123 or another or any another integer and still get reproducible result. Now you can verify it. You can just verify. Print training features comma x train dot and I would just be printing tab. Okay, and we have got all this. One bracket I put it in a wrong position, so let me correct it. See, we have got it all. So we first separate the input features x from the target variable y. Then we split the dataset into training and testing sets using an 80-20 ratio. The training set is used to teach the model while the testing set is used to evaluate how well the model perform on unseen data. Next, now comes the very important using algorithm. First algorithm which I will be using is logistic regression. So what is logistic regression? So it is a supervised machine learning algorithm used for binary classification problems. It predicts the probability that an input belongs to one or two classes. In this project, the model predicts whether a loan application will be approved or rejected based on the applicant information. Now, why it is called logistic regression if it's classification algorithm? See, this is one of the most common interview question. You can answer it has regression in its name because it computes a continuous probability between 0 and 1. That probability is then converted into a class using threshold, usually 0.5. Now I will be importing the model. First I would be writing logistic regression over here. Step 10. 3 more steps to go, but step 10 is logistic regression. First I would be importing the model from sklearn dot linear underscore model. I would be importing logistic regression. Yeah, so it would be yeah. Now I would be creating the model. To create a model, I would be writing logistic underscore model dot fit x train comma y train. Oh, one step I forgot. Sorry, my bad. Logistic underscore model. It is logistic regression. It is logistic regression. Okay. Now I would be running it. And X would be capital over here. See, our model is created. So what does fit do? Basically, the fit method trains the machine learning model using the training dataset. It learns the relationship between the input features xtrain and the target variable ytrain so that it can make predictions on new unseen data. Now we will be making the predictions. For that, I would be writing y underscore pred is equal to logistic model and x underscore test. So you can see that logistic model, it is not taking y, no, it is dot predict is also there, predict, and we can verify by printing. I would be writing print y underscore pred and see, it is predicting. So here 1 means approved, 0 means rejected because we encoded the target variable earlier. We initialize a logistic regression model and train it using the training dataset with the fit method. Once the model has learned the relationship between the input features and the target variable, we use the predict method to generate predictions for the unseen test data. Now we will do the model evaluation. Model evaluation. So basically, after training the logistic regression model, we evaluate its performance on the test dataset. Model evaluation helps us measure how accurately the model predicts loan approval and identifies areas where it makes incorrect precision. So for that, we will be importing evaluation matrix. So from sklearn dot matrix import first accuracy score, accuracy underscore score, and then we will be having confusion matrix, comma. Now for accuracy score, I would be writing accuracy is equal to accuracy underscore score and tab. and I would be printing the accuracy score. Print accuracy, comma, accuracy. And accuracy is 0.72. It is very less, but don't worry, we have other models also, so don't take tension about that. And let's convert it into percentage. So I would be writing print f of accuracy and accuracy into 100, two decimal values after that, and I would be closing and I would be writing percentage symbol, and we can see that accuracy 72.72. Now I would be printing print classification report basis on y test, comma, y pred, and we have got all this. Now we will be making the confusion matrix for this. So now this is the confusion matrix for logistic regression. Okay, as you can see that 0 are 505 and 1 is 202, and here it is 116 and here it is 31. Next is our step 12, which is decision tree classifier. Okay, now we have used one algorithm but its accuracy was less. No problem, we will use another algorithm and see how much accurate it is giving. So next algorithm which I have chosen is decision tree classifier. So basically a decision tree is a supervised machine learning algorithm used for both classification and regression tasks. It makes prediction by recursively splitting the data into smaller subsets based on feature values, creating a tree-like structure of decision rules. In this project, we will use a decision tree classifier to predict whether a loan application will be approved or rejected. So basically, let us first understand what is decision tree. Imagine you are a bank manager. Instead of using a mathematical equation, you ask a series of questions. Is your CIBIL score greater than 17? Yes or no. Income is greater than 5 lakh? Reject or no. Loan? Yes or no. Approve or reject. This is exactly how a decision tree works. It keeps asking questions until it reaches a final destination. So first we have import the model. Here you can see we have import the model. Next we have created the model here, and I have explained you what is random set. So again and again I won't be explaining you. And then we have our decision tree loaded. Next what we have done, we are doing the making the predictions. I will write it over here, make predictions. Make predictions. And here you can see that ypred.decision tree of x test we are predicting. Now we will checking the accuracy. 97.78. It is very much good. And you can all see the all thing precision, recall, F1 score and support. And next we have made the confusion matrix of this also, and it is over here. Next what we are doing, see it the problem is that unlike logistic regression, a decision tree does not assume a linear relationship between the features and the target. Instead, it learns a sequence of decision rule by selecting the best feature at each split. This makes it capable of capturing more complex patterns in the dataset. Now, interviewer may ask, why might decision tree perform better logic than logistic regression? So you can answer it. Logistic regression assumes a linear relationship between the features and the target variable. Decision trees can make model non-linear relationships and interactions between features, making them more flexible for complex datasets. But here's something every data scientist should ask. 98% accuracy is very high. So whenever you see an accuracy above 95%, you should ask yourself, is the model genuinely learning or it is overfitting? See, decision trees are powerful, but they can memorize the training data if allowed to grow without restriction. So let us verify the code which you can see on the screen. I've used it for verifying that it is overfitting or not. So as you can see that the decision tree achieve 100% training accuracy and 97.78 testing accuracy. This indicates that the model has learned the training data very well while still generalizing effectively to unseen data. Although there is a small gap between the training and testing accuracy, the model does not exhibit severe overfitting on this dataset. Next algorithm which I will be using is random forest classifier. So tell me, it is a supervised learning algorithm or unsupervised? Actually, it is both. We can use it in both. So basically, random forest is an ensemble machine learning algorithm that combines multiple decision trees to improve prediction accuracy and reduce overfitting. Each tree is trained on a random subset of the data and the final prediction is made using majority voting. Random forest is widely used for classification tasks because it is robust, accurate and performs well on structured dataset. You can imagine it asking 100 bank managers whether to approve a loan. Manager 1, manager 2 and like that 100 approved a loan. Instead of trusting one manager, you take the majority vote. Suppose 75 votes approve and reject 25 votes. Final decision approve. This is exactly how random forests work. Instead of one tree, it builds many trees. Majority voting, final prediction. Why random forest? Advantages of random forest: reduces overfitting, more accurate than a single decision tree, handles non-linear relationships, works well on structured tabular data, provide feature importance. So first we will import random forest. Here we have imported random forest. Next we are creating the model. You can see that I've created a model over here. Now let's understand what is this n estimators 100. This means 100 decision trees, majority voting, precision. Increasing the number of trees usually improves stability but also increases training time. Random state is equal to 42, keeps the result reproducible. Now we have trained the model. We are then predicting and then evaluating. And again you can see that accuracy is 97.78. And one thing you will observe that in both the before algorithm which we were doing, decision tree and random forest, we are getting the same percentage accuracy percentage, but it's completely fine. And what can be the possibility? Most likely the data set is relatively easy to classify, so both model perform similarly. And second possibility can be the random forest didn't improve because the default parameter was sufficient and the decision tree has already captured the patterns well. This is perfectly fine. Not every data set will show a dramatic improvement with random forest. And here you can see that all the precision, recall, F1 score and support are there. And this is the heat map. And you can see that training, and it is not a big difference, so it is fine, it is not overfitting. So random forest is an ensemble learning machine learning algorithm that combines the predictions of multiple decision trees. Instead of relying on a single tree, it uses majority voting to make more accurate and robust predictions. This approach typically reduces overfitting and improves generalization. Final comparison, you can see that the accuracy of this and feature important. So basically this is one of the best part of random forest because it tells us which feature influence the prediction the most. And this is the code, and see the CIBIL score were affecting the most, 80%. And you can see that this is the graph. CIBIL score is affecting the most, and then you have loan terms, loan amount and all that. So guys, this was the video, and I hope you understand this project. If you like this project, to this video, subscribe to my channel and you can comment out the things. Thank you everyone.